All right, let's get started. So with an allegation, you're going to have a prescription for a specific concentration that you don't happen to have in stock. What you will have is a concentration that is lower and higher than what you need. So let's take a look at our first example. We have a prescription for 420 milliliters of 4% potassium chloride solution. In stock, we have 1% solution and 8% solution. All right, so the first thing we need to do with an allegation is to set up our tic-tac-toe table, so to speak. Okay. The next thing we'll need is to insert the amount that we are after, the concentration that the prescription is written for, rather, in the middle. So we're after 4%. We write what we have in stock on the leftmost column of our tic-tac-toe table. So we have 1% in stock and 8% in stock. It doesn't matter where you put these numbers as long as one is in the upper left-hand corner and one's in the lower left-hand corner. The next thing we do is cross-subtract. And what I mean by that is you take 8 minus 4 gives you 4. And we take 1 minus 4, which gives us 3. Technically speaking, it gives us -3, but we ignore any negatives here. What we have now is we now know that it is 4 parts 1% and 3 parts 8%, which says something but doesn't really tell us what we need to know. The question on a problem like this would likely ask you how many milliliters of the 1% would be needed, or how many milliliters of the 8% would be needed. So what we'll do, the next step is to add our differences. We have 4 and 3. I'm going to add those together to get 7. So we know 4 parts of our 1% divide the total number of parts, 7, and 3 parts of our 8% divide the total number of parts, 7. Multiply those by our total quantity. And that's going to give us how many milliliters of each will be necessary. So we have 240 milliliters and 180 milliliters, but 240 milliliters of what? Well, you take 240 milliliters of the 1% and 180 milliliters of the 8%. So we know that in order to make 420 milliliters of our 4%, we need to use 240 milliliters of the 1% and 180 milliliters of the 8%. Alright, so on our second one, again, first thing we do is set up our tic-tac-toe table. Next we put the the percentage that we're after in the middle, and the percentages that we have in stock in the upper left and lower left. We then subtract. 90 minus 75 is 15. 50 minus 75 is 25, ignoring the negative again. We now know that we'll need 25 parts of the 90%, 15 parts of the 50%. We add up our total number of parts, 25 plus 15 is equal to 40. Now we figure out exactly what we're going to need. So 25 divide 40. I put that in parentheses just so you know to do that first. Multiply that by the total quantity, 30 milliliters. Here we have 15 divided by 40. And we're going to multiply that again by the total quantity, 30 milliliters. This gives us 18.75. And this gives us 11.25. 18.75 milliliters of the 90% and 11.25 milliliters of the 50%. So in order to make 30 milliliters of the 75%, we will need 18.75 milliliters of our 90% and 11.25 milliliters of our 50%. Alright, for our third problem here, we're given 4 fluid ounces. I would suggest that you go ahead and convert fluid ounces to milliliters. So instead of dealing with fluid ounces, I'd like to take 4 fluid ounces, and how many milliliters is that? For every 1 fluid ounce, there's 30 milliliters, so 4 fluid ounces would be 120 milliliters. Make sure you know your conversions. So we have 120 milliliters of 0.7%, and that's what we need. That's our prescription. In stock, we have 0.45% and 0.9%. To kind of circle back as to why I convert it to milliliters here, it's best to reduce the total quantity to small increments, and there's not much smaller than a milliliter, so we're going to do that. I'll explain why in just a second, but always convert your total quantity to either the units that you're after or a small quantity or a small unit like milliliter. I'll explain why at the end, you'll see. Alright, so we're going to write what we're after in the middle, which is 0.7. What we have is 0.45 and 0.9. Cross subtract, and 0.45 minus 0.7 is 0.25. 0.9 minus 0.7 is 0.2. We're then going to add our total parts. 0.2 plus 0.25 is 0.45. Take our individual parts. 0.2 divide 0.45. That's a 4. And down here we're going to take 0.25 divide 0.45. Multiply each of these by our total quantity, which we converted over to milliliters. Up here we are given 0.2 divide 0.45 times 120 milliliters. It's going to be 53.33 milliliters. Down here we have 0.25 divided by 0.45 times 120 milliliters. It's going to give us 66.6 repeating milliliters. And again, in order to figure out exactly what this is associated with, just trace it all the way back to the beginning. So it's that 0.45 figure. So that's of the 0.45%. Down here, trace it back to the beginning. You have this 0.9 figure of the 0.9%. So in order to make 4 fluid ounces or 120 milliliters of the 0.7% sodium chloride solution, you're going to need 53.33 milliliters of the 0.45% and 66.6 milliliters of the 0.9% sodium chloride solution. To recap as to why I convert it to milliliters, even when I convert it to a really small unit like milliliters, we still ended up with a decimal here, 53.33. Imagine for a moment if I were to have left that as 4 fluid ounces. It would look something like, 1.897 fluid ounces. It's sort of an inconceivable amount. It's difficult to put your hand on or wrap your mind around what 1.87 fluid ounces is. It's a lot better represented this way. It's a lot easier to measure 53.33 milliliters than it would be 1.87 fluid ounces. So I like to convert to small units when you're given a sort of larger unit as your total quantity with regard to alligations. All right, for our last one, we have 1 liter of 60% DOCUSATE suspension. In stock, we have 40% and 80% DOCUSATE suspension. So common convention would be that we would set up our tic-tac-toe table. We would then put what we have in the middle and what we're after, what we're after in the middle and what we have on the sides here. However, again, we have 1 liter. So I would assert that we need to convert 1 liter to milliliters. So in every 1 liter, there's 1,000 milliliters, right? So that's our total quantity, 1,000 milliliters. 60 is in the middle. Now, this is an interesting scenario, and I'll explain why. When you cross subtract, you end up with 20 down here and 20 up here. And remember, this is the amount of parts. We have 20 parts, 40%, and 20 parts, 80%. If we were to carry it out, you'll see 20 out of 40 times the total quantity, which is 1,000. And then over here we have 20 out of 40 times the total quantity of 1,000 again, right? So we're going to end up with the same number. We're going to end up with 500 milliliters of each. So why? Why do we have the same amount, same quantity required for both 40% and 80%? Well, the easy explanation is that 40% is 20% away from what we're after, and 80% is also 20% away from what we're after. That's not to be confused with the amount of parts here, but what I'm getting at is that when you have two quantities that are sort of equidistant or equal amounts of part, the difference is the same. So here, they're both 20% away from what we're after. What I'm getting at is that when the differences of what you have and what you need are the same, you'll use equal amounts of both. So here we have 40% and 80% going after 60%. We're going to need equal amounts, 40% and 80%. It's a 1-to-1 mixture. So when you have equal amounts and you only have 2 parts, half of it is going to be 40%. The other half of it is going to be 80%. So that's sort of a quick way without working through the alligation. If you have lesser concentration that's the same distance away as a greater concentration, you don't need to work out the alligations, just half and half. It's important to remember that. It could save you a lot of time.